Hello, YouTube. Joe Holbrook here, the Cloud Tech Guy. Wanted to go through the Certified Blockchain Solutions Architect Bootcamp. This is session number 2. This one here is one of the more important mini bootcamps you'll have for this exam, because on this exam you're going to be really required to know the difference between the consensus algorithms, but specifically focus on proof of work and proof of stake. Let's go ahead and talk more about this. When it comes to consensus algorithms, one of the things to focus on is to know the difference between these algorithms. But before we get started, let's make sure we understand what mining is and what consensus is. We're going to talk about proof of stake. We're going to talk about proof of work. We're going to talk about the pros and cons of each and compare them. We'll also talk about some of the other algorithms like BFT. We'll talk about hashing. We'll talk about DPoS. Just the major algorithms. There's like a total of, I think, 8 total we'll talk about. And then we'll compare those algorithms. And then there's some review questions. So in this session here, I'm going to mainly focus on the consensus algorithms, proof of work, proof of stake. That's where most of the focus is going to be, because again, on the exam, you want to know how to specify the right blockchain algorithm for the right use case. We'll talk about delegated proof of stake, BFT, which is Byzantine fault tolerance, proof of authority, proof of weight, that is. We'll also talk about hashing as well. Let's go ahead and talk about mining first. Now, when it comes to mining, most people think of Bitcoin, and that's really probably a really good start. And the reality is, again, Bitcoin was the original consensus algorithm that used proof of work, which really used mining. And the goal of course, mining is, processing those transactions that are written to the public ledger. So when user A sends money to user B, remember that this is a distributed peer-to-peer network. There's no intermediary that is essentially, validating you can send money. You're not using the IMF or not the IMF, but you're not using like a central bank or your local bank to do this. Now, generally when we talk of, Bitcoin, it's the proof of work algorithm. This was the first blockchain consensus. This was really developed by Satoshi Nakamoto for the blockchain network. The goal of the blockchain is to confirm transactions to the rest of the network, and every node needs to validate that transaction. The Bitcoin nodes uses the blockchain to distinguish legitimate Bitcoin transactions from attempts to respend coins that have already been spent. Now, that's known essentially as a double spend issue. We'll talk about that when we get to proof of work. Now, mining is called mining because it does sort of resemble mining of other commodities. In other words, for you to go out and mine silver or copper, and if you've ever been to a copper mine, for example, it's pretty fascinating the amount of energy that's used just to dig up copper. You dig these massive holes in the ground with large, super, oversized dump trucks and other, mainly Caterpillar equipment is from what I have seen. So pretty interesting stuff. Now, with mining, with cryptocurrencies, you have these essentially servers that are, using really massive amounts of energy, electricity, and they're generally using really high-end processing power. Now, and, again, depending on the algorithm, like Monero is going to be different than Bitcoin and Ethereum, but you may need to have, an ASIC versus just being able to use your laptop like Monero, for example. So once again, the amount of power that's used to validate a Bitcoin is very substantial. Now, Bitcoin uses the Hashcash proof of work algorithm. And you may want to remember that as well. Hashcash proof of work. Now, what is a reward? Now, a reward is, for anyone that's participated in mining, you pretty much know what this is already. But if you haven't, just remember that a reward is given when a block is discovered. Now, I like to compare Bitcoin mining to like a race. It's like a marathon. And for example, mining as a service is a good way for folks to get into mining if you don't want to go out there and purchase, tens of thousands of dollars of equipment to get into like Bitcoin mining. Genesis mining is a good example of that. You have the ability to mine Litecoin, Bitcoin, Ethereum, Monero, for example. Now, when it comes to consensus algorithms, once again, these are implemented as part of the node application. And again, this is how the transactions are processed through, that algorithm. Again, it's really dependent on, is it Bitcoin or is it Monero? Is it, or is there not going to be any kind of tokens or cryptocurrencies, right? If you're an enterprise, then you're probably not going to be worried about, tokens or even cryptocurrencies. But again, it really depends on your use case. But the goal of the algorithm is to determine the method for coming about to what's called the world state. Now, the world state is basically saying what is the snapshot, essentially, of this blockchain at a specific point in time. Now, proof of work, for example, will be Bitcoin, Ethereum, Litecoin, and that uses, again, different algorithms that are proof of work. You have 2xSHA, 256 for Bitcoin, Ether hash for Ether, so on and so on. Now, we'll talk more about those coming up here shortly. So let's go ahead and talk more about the algorithms. Now, on this exam, you do want to be very knowledgeable in proof of work and proof of stake, and also be able to distinguish between delegated proof of stake, Byzantine fault tolerance. Also, too, another term you may not be aware of is a DAG. That's a directed acyclic graph. And then other algorithms I'll touch on as well. Now, when it comes to algorithms, proof of work is, of course, the original algorithm. This was the first one that at least was documented by any kind of decent white paper. There may have been other use cases, but from a historical perspective, Satoshi Nakamoto created the Bitcoin blockchain. Now, it's also important to understand that because of this blockchain that Satoshi had developed for Bitcoin, it also opened up a lot of opportunities for folks to get in on the cryptocurrencies and become a miner, and allowed a lot of people to make a lot of money with Bitcoin, especially early on. And now the proof of work algorithm essentially runs on a system of the longest chain wins. And so what exactly does that mean? Well, again, a lot of the ability for you to make money as a miner is you have to be able to participate in that marathon, and you have to get to the finish line. And so having the biggest, baddest equipment is really the best way to do that. Now, in proof of work, miners are going to solve these problems essentially and create blocks. Now, with the POW algorithm, it essentially runs on what's called the longest chain wins approach. So basically what that means is most miners are working on the same chain, but one will grow faster than the others and the longest, and one will become essentially the most trustworthy. And that's sort of where we get that sort of 51% issue come in as well, and we'll talk about that when we get to the POW section, but just the compare and contrast, that is. But just be aware that Bitcoin is considered safe, for example, as long as you don't have 50% or 51% of the miners taking over, essentially. It's expensive, again, very expensive. It's environmentally expensive as well. Bitcoin, Ethereum, Litecoin are good examples of that. Okay, so let's go ahead and speed it up a little bit. We'll talk about delegated proof of stake, for example, after, but let's talk about proof of stake. So proof of stake, the blocks are not created by the miners doing work. In reality, this is more like, almost like compare it to gambling, where you put up money and you hope that you're going to sort of get a return on that money. You're not really doing any work. You're not going out buying really expensive mining equipment or anything. But what happens is that the minters are essentially being able to stake their coins and bet on what is going to be valid and what is not. Now, generally in proof of stake too, the bets, again, it's really considered a bet. And what happens is that that amount of money that was put up in tokens usually is going to be betted on which block is going to be correct at what exact time, and really depends, of course, on the algorithm on how that's handled. Now, it's basically a voting approach. It's also considered voting in some algorithms as well. But generally, most people want to vote on what's called the correct fork as well. Basically, if you vote on the wrong fork, you could lose your stake as well. There's a lot more to this, but it is less environmentally expensive. And then Purecoin is a good example, and Ethereum will be going to more of a proof of stake algorithm here in the future. That is something that is expected, I understand, sometime in the next probably 7 or 8 months, but we shall see. Then we have what's called the DPoS. That's delegated proof of stake. Now, with a delegated proof of stake, this is sort of comparable to like you going out and voting, where you vote for who you want to win the election. Basically, miners can collaborate to make blocks instead of competing. And so what happens is this is a little bit different than, well, it's actually a little bit more than a little different, but in reality, DPoS really does this. It's like basically if you're holding on to tokens, you don't vote on the validity of the blocks, but you really vote to select specific delegates that are going to validate the blocks on your behalf. So it's almost like, going to the election, and in the background you have this like electoral college. It's really an interesting algorithm, and this was developed by Daniel Larimer. This is a very new approach. Generally what happens in DPoS is that there's going to be elected delegates, and I believe it's like at least 20 to 100. Really depends on the algorithm and in the blockchain. Now, Steemit's a good example of that in EOS. But when it comes to DPoS, miners essentially collaborate instead of compete. That's really the difference. For this exam, just realize that DPoS is more of a collaboration than a competition. One thing to point out too, DPoS is centralized. That's a big deal to know. Okay, let's go ahead and talk about BFT. Now, Byzantine fault tolerance is an interesting algorithm in the sense that it's been a problem, but there's also a solution. Now, this is the classic problem where you had all the generals surrounding the castle, and different generals from different divisions of the army. And, in the old days, how did you communicate? You had to send messengers. You didn't have walkie-talkies and radios and phones. Now, pre-selected generals basically meant that there was some kind of privacy to the communications. Another thing, too, about Byzantine fault tolerance is that it's very efficient. There's very high throughput, but it's very centralized. A good example of this could be using this with Hyperledger, Ripple, and Stellar. Now, there's also, now just to point out, I want to just, there's actually a couple approaches to BFT. You have Byzantine fault tolerance, but then you also have PBFT. This is actually a little different. This is practical Byzantine fault tolerance. This is really one of the first solutions. It's used with Hyperledger Fabric, for example. And you generally do have essentially fewer generals, like less than 20 running the show. Some of the pros with this, though, is that you have, of course, the higher throughput, but the con is it is centralized and permission-based. So just clarify that. And then we have what is called a DAG, or a directed acyclic graph. Now, this is an interesting take on the world because this is a form of consensus that doesn't use the blockchain. So again, it's like a hybrid, I guess you'd really consider this, because it's not really a blockchain per se. It's also known as a blockchain killer, and we'll see where this goes in life, I guess. But it's a way that transactions are handled asynchronously. And this is supposed to scale like infinitely. Now, as you're aware, you can only process, so many transactions per second on Ethereum, Bitcoin, even the Visa network. Again, it's an interesting approach. So basically, DAGs are basically a form of consensus, but it doesn't use the blockchain. So how could that be? This is really an odd approach. But basically, the way it handles stuff basically is that there's, for example, Tangle is a good example, or IOTA. So like in Tangle, the consensus algorithm is used by IOTA. And basically, when you send a transaction, you have to validate its two previous transactions. And then once that happens, you have what's called like a 2-for-1 play, or it's also considered like a pay it forward. So if you can make one transaction, you're really paying for two. Interesting approach. But then again, for this exam, you want to be aware of it. There's no deep dive into this, so just be aware. Okay, let's go ahead and really compare POW to POS, because this is where the meat of the, at least from what I would say on the exam, the meat of the questions would really be focused on. You want to know proof of work versus proof of stake. Now, be aware that just look at this. Now, of course, I could have probably did a left and a right graph, but I think this is more effective. When we look at proof of work, it's more of a reward approach. In other words, the miner is getting compensated for winning the marathon. And then with proof of stake, you're basically putting up tokens or some kind of deposit, essentially, to be able to bet on a certain outcome. Proof of work is more secure, but it's slower. So think of proof of work as like the turtle, whereas proof of stake, might be the rabbit. It's faster, right? Now, proof of work is decentralized. It's totally decentralized when it comes to Bitcoin. In other words, you don't really have, however, you can make an argument against that, to be honest, if you look at how mining's handled, because mining in Bitcoin is really becoming highly centralized. But when it comes to the blockchain, it's distributed on every node. And so there's no one, one node controlling the blockchain per se. Proof of stake is more centralized. So if you use Hyperledger, Corda, for example, these are going to be centralized approaches. Not that they all use proof of stake, but just as an example. Permissionless or permissioned. Now, once again, permissionless is going to be your public blockchains generally where anyone can join and view the transactions. For example, you'd use a blockchain explorer. And permission is different in the sense that this is more for your private/enterprise blockchains. So for example, this is like Ethereum versus Hyperledger. And when I go through the course, those are the two main blockchains I'm going to talk about. I'm going to talk about Ethereum and I'm going to talk about Hyperledger. Those are really the two poster childs of blockchains right now. Proof of work is a proven consensus algorithm, whereas proof of stake is a younger and sort of unproven as well. Now, to get into proof of work mining, again, it's a heavy investment. It's a big investment. Whereas with other proof of stake, it's a little different, like Dash. Dash is sort of interesting. It's more of a hybrid proof of stake, but it's still considered proof of stake. And Ethereum will actually go down that road as well. But just as an example, the hardware investment could be significantly different. Now, energy intensive. Proof of work is very energy intensive versus proof of stake, which is much more energy efficient. One of the challenges that you'll want to know for the exam is with proof of work, you have an issue called the 51% attack. This is where the mining gets too consolidated. And it's possible when you have the 51% attack that the blockchain could essentially be hijacked or transactions could be denied. And then proof of stake has an issue where you have nothing at stake. And that could be solved with what's called slashing in some of the consensus algorithms. And then lastly, we have work versus relative value. That's sort of the difference when it comes to comparing the different consensus algorithms. So proof of work is going to be really utilized, again, in blockchains that are probably going to be public. Proof of stake is going to be really more focused on a centralized approach. So as an enterprise architect, you're probably going to use proof of stake. However, can you go out and tie into Ethereum or Bitcoin down the road? Sure, you could, do that. You could do what's called an off-chain transaction or whatever you want to do. Use smart contracts or, many different ways to approach it if you wanted to do that. Okay, let's go ahead and see how we did here. Okay, let's go ahead and talk about some review questions here. The first is, what are some advantages of proof of stake mining over proof of work mining? Select 3. So go ahead and take a second. I'm not going to read them to you. Take a second and see how you did here. We'll go ahead and proceed on and show you how you did. And remember, select 3. Okay, let's go ahead and see what the answers are. So it's the first 3. Basically, with proof of stake versus proof of work, there's less need for expensive hardware, the transactions are faster, and it's more energy efficient as compared to proof of work. Now, proof of stake doesn't typically, from a security standpoint, really have better security. There's different challenges. And faster hashing process, that's not really true at all either. So just think of proof, again, look at the differences and just be able to pick out what the best answers are. Okay, let's go ahead and look at this one. What are 2 reasons that you would consider implementing a proof of work algorithm in your blockchain? Go ahead, take a minute See how you did here. Okay, so the correct answers would be B and C. Basically, proof of work imposes limits on actions in the network and therefore can thwart attacks better than other algos. And again, this is due to the high cost. Remember that you have miners that are, essentially solving problems or doing work. So that's where the high cost comes in. And then you have computational power, right? They're solving the puzzles, the problems. And again, they're not really having per se a financial stake. That's more in proof of stake, for example. And the other answers are not correct as well. Okay, last question. Blockchains are decentralized ledgers, which by definition are not controlled by a central authority. Due to the values stored in these ledgers, bad actors have huge economic incentives to try and cause faults. What algo was the original solution to the potential problem? Go ahead and take a minute and solve it. Okay, proof of work was the original. Remember, Satoshi Nakamoto was the one that really solved this problem with the Bitcoin blockchain. Okay, so that's about all that I had for content and questions. If you need additional help or you want to practice your knowledge, I have over 100 plus questions, around 130 or 150, I don't remember exactly, but to help you out and prepare for this exam. And then there's also additional blockchain training as well. I have seminars that I'm doing as well. And I'm also doing some live online training with Pearson as well. Thanks for your time, and please reach out if I can help you. And please do subscribe if this content is of interest to you.